It's the video you've been waiting for, part 3 in our Deephaven performance demo. Now, if you need context for this or to get some information on the scripts that I'm going to be running, feel free to watch part 1 or part 2 of the video. This one kind of just jumps in there and sees how the scripts run side by side in Deephaven and Materialize. Okay, let's get started. Here on the top left, you will see is the UI for Deephaven, in which case I've run all of the scripts and we're going to be monitoring this page view summary table. Now on the bottom left, I have the watch command executed on our materialized view. And so you can see that this is exactly the same total coming into Deephaven and Materialize. I have the rate right now set at just 1 page per second. So something that I know both can keep up with no problem. Now on this bottom right is the top command. And so as we start to put more load on this system, you're going to see that the amount of load on the various processes is going to go up and down with time. I like to put things to the limit, so my goal here is to see which one breaks first and see how they break and whatnot. And so we're going to push it to the extreme. Now we're using Red Panda as our Kafka compatible message queuer. And so that one's going to be sitting there and it's going to be going up with CPU and memory. We have Materialize, and this is going to be the command that you're going to watch for the Materialize, and then Java, which is the Deephaven instance. So in the top right is where I'm going to connect to the load gen script, and that's going to allow me to change the amount of page views per second that we're going to execute. So I'm going to go into the load gen, and now I'm going to change it. So right now I have it set at 1, and I'm going to increase it to, let's say, 100. And this is going to be able to get a few more page views per second. So we're going to hopefully see this total number come up just a little bit. And then as more and more page views per second go into Deephaven and Materialize, we're going to start to see the DT_MS lag behind a little bit. And so what that is essentially how long does it take for that page view to go onto our Kafka queue and then into the database. And we know that with big numbers, we really want it to happen fast. And as the numbers increase, the question is, how can we keep up with those numbers? And so here you can see that we now have the Materialize is taking up 95% of the CPU. The Deephaven is taking up 26% of the CPU. And then as far as our RAM is concerned, we have the Materialize is taking up 202 megs and the Deephaven is taking up 1.5 megs. Now, that's just with 100. Let's change it a little bit and let's put a little bit more stress on this. And let's change it so now we're getting 1,000 page views per second. Okay, so it takes a few seconds for this to kind of catch up and the system to calibrate. And so as it does this, we're going to be looking at this total number. And I like to watch this to see essentially which total number is going up faster, because that gives me a clue as to which one is keeping up better with the system. And here I'm seeing that the Deephaven 1 number is a little bit higher, so that means we're processing those results a little bit faster. Now let's look at our resource management. In the bottom right, the top command, I'm seeing that Materialize is now 200% of the CPU, but Deephaven is taking up 1.7 gigs of RAM. So if you're CPU limited, then you might want to switch to a Deephaven type of thing for this. If you're RAM limited, then it seems like Materialize is winning out. Okay, so that is with 1,000. Now 1,000 page views per second is a pretty reasonable number, but like I said, I want to push this to the max and see kind of which one breaks and how they break. So I'm going to take it, and now we're going to push 10,000 page views per second. Now, I want to give you a word of caution that if you're doing a perf test like this, you want to make sure that you're on a machine that can essentially accommodate this type of testing. The machine I'm using is actually a VM instance on Google Cloud, and it has 16 CPUs, and it has 64 gigabytes of RAM. And I've allotted 32 gigabytes to just this performance test. And so you can imagine that's a lot of resources that I'm performing to this. So I highly recommend that you don't do this on your personal laptop unless you've set up some instance like on the cloud or whatnot. Okay, So now that 10,000 is in the system for a few seconds, we're starting to see a little bit more lag in the Deephaven table. We're now up to almost a half a second of lag. So that means that page view coming into the system takes about a half a second for us to register it in the system. Now, notice the Deephaven number right here is 650,000, whereas the Materialize number is a lot less. And so that means we're keeping up with it. Deephaven is able to have more of those transactions than the Materialized one. Okay, so that's 10,000. Now, let's do 100,000. And if the people are watching my VM instance on Google Cloud, you might start to see smoke coming out of that server. I apologize for that, but that's just the nature of performance testing. Okay, so now we can see that Materialize has actually beaten out all of the other processes on my computer and is taking up 327% of the CPU and 6 gigs of RAM. Wow, that's just for Materialized. And if I look at the time in seconds of that lag, we can see we're almost, well, now we're up to 24 seconds. So that means it's taking 24 seconds for that operation to go into the scripts and then onto the Materialized table. Now let's look at the Deephaven one. That's our Java process. We're taking up 170% of CPU and 1.4 gigs. So you can see that both Materialize and the Deephaven instance have increased in that CPU and the RAM. However, the amount of increase for the Materialize has really increased at a higher rate than the Deephaven instance. And if we're looking at the Deephaven instance, we'll see that our lag is now 1.6 seconds. So moral is that we're able to keep up with it a little bit better. One of the things to note is we have logged on Deephaven over 8 million page views, whereas the Materialize instance is almost 2 million page views. So that means we're logging about 4 times the amount of page views as the Materialize instance. Okay, so I want to put a caveat in here that there's a whole bunch of use cases for Deephaven and a whole bunch of use cases for Materialize, and they kind of come from different sectors of the data world. And so depending on their use cases, your results may vary. But in this case, you can see that with this large of a number, 100,000, that Deephaven is able to kind of keep track a little bit better. But I kind of wanted to see how this would die, right? So my goal with this was to watch the system die. So let's do 1 million. And let's see what happens. In this case, this is a lot of page views per second, 1 million. And we're sending all of them to the one Kafka server and one Deephaven and the one Materialize. And so that means we're really putting a lot of load on these. And so as it's starting to do this, I expect that the system will be kind of reached the max and kind of topping out. And here you can see, oh my goodness, it is. And so Materialize, it's taking 17 gigs, and the Deephaven is taking almost 12 gigs of RAM. So that's quite a bit for the system. Now, as those numbers build and build, at some point, the Docker containers are going to run out of memory and the entire system will crash. But it seems like these are pretty robust and it'll take a while for that to happen. And by then, well, I would probably have lost you. So if you want to know more information about this, feel free to hit us up on our Slack channel. Till next time, bye.